Hello everyone, my name is Ahmad Alsaleem, and I'm going to present to you today Experience is Not Required, Designing a Sailing Experience for Individuals with Tetraplegia. This work has been done at the University of Utah with other collaborators that you can find their name on the slide. Hilary Lister is a quadriplegic sailor who sailed solo across the English Channel using a tube. Hilary Lister once said, "I had no idea whether it was manageable or not, but I was frustrated that everyone around me was learning to sail and I was still a passenger." Sailing is hard and requires a lot of training. This is more true for people with different abilities, as Hilary Lister learned, as they need a crafted design to fit best their abilities. Sailing is a learned skill that requires a lot of training. For example, a sailor needs to understand how to utilize wind movement and direction for speed and control. Typically, a user is expected to go through a training process before actually sailing by him or herself and continue that training process on the water. This can be a problem for our users, as they have multiple health conditions that might prevent them from enrolling in such a traditional training process. Also, adaptive sailing experience offering are very limited, as we learned despite our best effort, we were only able to offer our participants, on average, once a year chance to sail with us, due to many logistical barriers such as cost, transportation, and most importantly, participants' health condition that might prevent them from joining our experiences. To overcome these challenges, we wanted to do two things. First, creating an accessible sailing system. Second, changing the training process to make it more adaptive and more responsive to the patient needs and level of experience. After over 5 years of work, this resulted in Tetra-Sail. Tetra-Sail is an adaptive sailing experience that relies on the idea of shared control. In shared control, two parties, we refer to them as a control partner and the main user, collaborate together to control the experience. So how we got there? We started by creating a Tetra-Sail hardware that matches the experience, the feel of a wheelchair in terms of steering and the control system. We hope that such design will make our participants feel competent and familiar with the system. To achieve the second goal for our system being adapted in the training process, we decided to have onboard human instructor that would help participants with their sailing experience. These goals resulted in Tetra-Sail V1, as shown in the slide. We use commercially available kayak system. We outfitted the system with customized seating and straps for the user, similar to what he or she used to have in a wheelchair. Also, we modified the wheelchair input system to work with our newly modified rudder and motor system, giving the user the ability to control turning and motor speed of the system. For the instructor, we provide him a manual disconnect system that helps him to turn off the system when risk is imminent. Talking about more depth details about the input system. The input system we use are a joystick and a sip and buff. Those devices covers a wide range of our participants' ability. Joysticks works as any traditional gaming joysticks. The sip and buff on the right side is an input device that requires no motor ability from the user. Sip and buff is a mouth-operated device, uses air pressure sensor to detect changes in the pressure. A user inhaling air from the tube will trigger a sip command. A user exhaling air in the tube will trigger a buff command. While we had some success with Tetra V1, we found multiple issues. For instance, we found the control system that we borrowed from power-assisted wheelchair was not responsive enough for the needs of the experience, as they have built-in delays that are suitable for wheelchair context but not for sailing. Also, we could not expand or change the commands of the input systems provided, which constrained us from expanding or changing the functionality of Tetra-Sail. On the other side, the instructor was overwhelmed by the combination of tasks he needed to perform. As we find it, the instructor needed to keep monitoring the health of the user, debugging and fixing any sudden technical issues with the prototype, moving physically on the boat to control the various components to help the user sail, and on top of all that, instructing the participants on what he or she should be doing. To address these problems, we started our second iteration to Tetra-Sail. In this iteration, we focused on making the control system for our user more usable and functional. Also, we resulted to design a new collaborative system, shared control, to facilitate the control between the control partner and the main user. We use an Arduino-based microcontroller to reproduce the functionality of a wheelchair joystick and a sip and puff system. Creating our custom control input devices allowed us to design and implement our own algorithms that allowed us for better detection and faster response that's required for the context of the selling experience. In addition, allowed us to expand the number of commands we can have from those devices. To help the instructor with his or her various jobs, we designed a wireless remote control system. Using the remote control, we allowed the instructor to have a more active role in help controlling the experience with the user rather than just performing emergency brakes for safety or just relying on verbal communication for instruction. Also, having wireless remote control with various control functionality allowed the instructor or the control partner to be close to the user at all times, to be more focused on help instructing and monitoring the health condition of the user. In parallel, we designed a training simulation that would help our participants get more familiar with the input system and the basics of sailing before the actual sailing day. Also, the simulation helped us to test and try different input systems and schemes with participants when it's convenient for the participants, which helped us design better systems without need to interrupt their participants' limited experience on the water. With a simulation, we aim to convey all types of information a user might need in his or her sailing experience. After deployment, we found users expecting the same level of information in the real-world experience, which was costly and sometimes infeasible. For that, we started designing the UI in the simulation based on what we can really replicate in the real-world environment. For instance, we reduced the visual representation performed command and replaced that with a speaker system that announces the performed commands in both the sim and the real-world experience. To understand better our users' reaction to Tetra-Sail, we designed a study. Please refer to the paper for more details and information about the study. Participants reported that they really enjoyed the shared control as it did provide them adaptive training suitable for their level of experience. Also, participants felt the control partner did support their level of their independence controlling Tetra-Sail. As one participant said, "I really enjoy hanging out with the control partner. He just gave me a lot of control." I want to end this presentation on the note of what we'll be working on next. We know that we're still having the control partner performing a lot of tasks, and we're thinking how we can automate some of these tasks for the control partner. This is very important work for us. It will answer the question how to create a computer assistant and a human assistant that both work collaboratively to help our main user. Till now, we know the communication part is best suited for a human-computer partner, but automating the technical debugging and fixing is best for computer assistants. In conclusion, shared control allowed our participants having enjoyable sailing experience regardless any prior sailing experience. And Tetra-Sail simulation serves as a great design tool for the actual real-world experience. Thank you for your time watching this presentation.